Welcome back everyone to another video in our FE Civil Preparation course, and in this video we are going to talk about slope stability. During construction, many times we need to dig trenches, and sometimes instead of providing a shoring system, we can rely only on a sloped embankment, as we can see here. The stability of this embankment needs to be studied to avoid the soil sliding and the slope failure due to the shear failure, as we have learned in our previous video. In order to study the stability of any slope, we need to assume what we call a planar slip surface, which is the surface we want to check if the soil may slide on the top of it or not, and the angle between the horizontal axis and this plane is called alpha s. After that, we will deal with the problem as any mechanics problem for friction force. We will have here the weight of the soil above the plan here as Wm, and of course the weight is always vertical. This weight will have a component parallel to the assumed failure surface in the sliding direction, and this is called the T mobilized, which is the mobilized shear force along the slip surface, and it equals to W sine alpha s. This weight will have a component parallel to the assumed failure surface in the sliding direction, and this will be called T mobilized, which is the mobilized shear force along the slip surface, and it will equal to W sine alpha s. After that, the stability force will be calculated, which consists of two different components, as we have also learned in our previous video. First component is due to the friction force, which equals to the component of the soil weight in the direction vertical to the plane of failure, which equals to Wm cosine alpha s, and this force must be multiplied by the coefficient of friction for soil, which equals to tan phi, where phi is the angle of internal friction for the soil. And the second component is due to soil cohesion, which equals to C multiplied by Ls, where Ls is the length of the surface plane and C is the soil cohesion. So this means that TFF, which is the available shearing resistance along the slip surface, will equal to CLS plus Wm cosine alpha s tan phi. So the factor of safety will equal to TFF over T mobilized. So now let's have an example on this. So let's check this example. We have this slope here with angle of 20 degree, height of 15 meter, and the weight of the soil above is 3036 kilonewton per meter. The cohesion of the soil is 19.2 kilopascal, and the internal angle of friction is 15. And we want to calculate the factor of safety against sliding. First, we will start by calculating the sliding force, which equals W sine alpha. Here we have W, which is the weight, equals 3036, and alpha is the angle of the slope, which is 20 degree, so the sliding force will equal 3036 sine 20, which equals 1038 kilonewton per meter. After that, we will start calculating the resisting force, which equals L multiplied by C plus W cosine alpha tan phi. We want to calculate the L. We can calculate it from this triangle. It equals 15 over sine alpha, which is 20 degree. So 15 over sine 20 equals 43.8 meter, which is the diagonal length of this slope. So the resisting force will equal 43.8, which is L, multiplied by 19.2, which is the cohesion, plus 3036, which is the weight, cosine 20, which is alpha, tan 15, which is phi. All of this will equal 1606 kilonewton per meter. So the factor of safety will equal the 1606 over 1038 equals 1.55. So the closest answer is A, which is 1.6.